Good evening. It is Sunday, March the 20th, about 8:30 p.m. My name is Shay Gibson with Weather Flow and Wind Alert, and this video is in correspondence with Rick Iosi of the Florida Kitesurfing Association, who has done an article on a waterspout that developed off the beach of Fort Lauderdale yesterday. The big question is whether or not this was an actual tornado before it hit the water. And also just studying the science of this thing. If you look at the video here over me, you can see the actual width and the size of this waterspout. It's not your typical looking waterspout. It looks more like a low-level funnel cloud because of its diameter and width and where it originated from. Typical waterspouts, you may see a truncated helix going from this water surface all the way up to a cloud base, and this one actually looks like the clouds have come down to the surface, which tells me it's more of a low-level rotation or funnel cloud system. So here is the lifeguard tower that video was taken from, right here looking towards the north. I pinned right about here is where that waterspout developed along the beach and then slowly eased off to the east-northeast. It didn't move very fast. It did stay along with its base of the convective cell that it was underneath. So one thing we always want to do is we have to look at maybe what the winds were doing at the time, and we know that there was an onshore flow going on, a southeast wind. And then as the storm went out, it may have had an outflow pushing in from the west just ahead of it. And sometimes when you get that, you get a low-level rotation that begins, and you actually get some vorticity that may start as a result of this opposing wind direction. So you have an undercutting south wind, and then you have a downward cutting westerly wind from ahead of a convective cell, and that can get a real spin going, especially as convective cell moves from land over the ocean. So the water temperatures there are up just enough to be able to support waterspout activity, and that's all you need. And even sometimes early mornings or at night times under these cumuliform clouds, you get just a little bit of a 5 or 10 knot wind here, just a little bit of an offshore westerly wind, and that can start one of those famous waterspouts that are known for that area. But this one was a rather large swath. I believe it began probably somewhere in this area here and then slid off to the east-northeast and then eventually curved to the northeast and followed the convective cell that it was under. So pretty tricky situation there. I want to definitely look at the skew T for the morning and the values that were given. This is from the weather balloon upper sounding. We call this a radiuson. And the weather balloon values for 7 a.m. in Miami were very low for any kind of tornadic activity of 80. Usually this number right here is the one you want to look at. So 150 to 250 is where you start to get where tornadic values are coming up, where surface helicity is actually on the rise, where you get some relative storm helicity values to be able to support tornadic activity. So not fully convinced that this was a tornado just based on some of this criteria. Even over here we see that the TOR monitor definitely had some lower values there. We did have the storm was moving right to left according to the hodograph here to the right, and we did have a little bit of opposing wind here. Southeast at the surface goes up to west at the top, so there's a little bit of shear going on there. So there is some potential for some rotation to go on, but nothing really that much in way of severe or tornadic warning or tornadic watch activity for the skew T that's issued for the day from the National Weather Service in Miami. Now looking at the data scope for the area, and this is our weather flow product that we use, we see that this is about the area right here where the waterspout went. Here's some of the witness from Sylvia Lake said that there was some banding coming up from here. We had a southeast flow here. This thing formed and went off in this direction here. Our weather station, we don't have anything that close by. There is a weather station near here. I think it's offline at this point. Station's down. It was up yesterday. It didn't really record very much. As far as yesterday, we did have some outflows that were recorded. And if we go back in history yesterday, we look at some of these values, we're seeing up about 37 miles an hour, and that was about 3:45. Let me take a better look at this in some of the details. Now, granted, this station was to the south, but it does prove one thing. It proves that there was southerly flow during that time. If we go back and look, you can see the southerly flow here, and there's a little bit of a shift from that outflow there at that time, or just before that time, and then the southerly flow resumes, and you can see some of the gust lines coming up to the upper 20s, which would be in agreement with some of the videos where you saw the water chop really streaming towards that funnel cloud, and that's all that convergent air coming in from all directions. We had it from the west, from the south, from the southeast, all those directional winds coming towards that to support the vorticity along the surface of the water. And so we have to look at some of these lower values down here as well on the turn. So after this little event right here, just before 3, where there was a convective cell that went through. Then we saw the winds turn from the south again, and then that's where you get that little bit of a higher westerly nudge to get that vorticity started. But the highest wind speed that was recorded yesterday was right here at about 37 miles an hour. I believe that was at about 2:45 p.m. So here's Rick's FKSA article for right now. What we're seeing here, there was some kite activity on the beach just to the north of it. I think he was kind of pointing out that, hey, it might not be a good idea to be on the beach during those things, especially with the water spout going. Here's a picture of the spout here from one of the higher rise buildings. And here's some of the damage that was done. You can see some of these catamarans laying around on the beach here. They were definitely moved around, shifted. Some of them were broken. There was some other gear, some water gear busted up as well. I think one of these pontoons was broken in half. So definitely some damage on the beach, which it verifies that this rotation definitely started on land before it made the water, which would classify that as a tornado to a waterspout versus the other way around. So we'll wait to hear back from the Weather Service on that and see what they say. I definitely wanted to take a look at the other video that I had for this, and that would be this one right here. Now this one shows a much larger swath off the coastline here, and you can just see how wide this thing is, and it's not like your typical waterspout, and it's just impressive in size. And this thing just slowly kind of goes off to the northeast. Now I want to go into the radar, take a look at the radar for the area. Now this is level 2 radar that I downloaded yesterday, and I want to look over the area, sort of recreate the event. So I'm going to pause it right about here as that storm line comes down from the north, and right about here is the cell that reached the coast. It's just north of this that says Fort Lauderdale. It's right here. I'm going to back up one, and I'm going to zoom into the area. Let's try to get a 3D image of it. I'm going to blow it up. You're going to see about 2 or 3 convective areas in this 3D rendering. There's one, there's 2, there's probably another one just off to the side there that you can't see. But this one, we're looking for rotation within this. Now if it's over the water and it only has water vapor, that imagery may not show up. But we're going to turn this back facing north to south, and we can see a little bit of a swath of water right here, a little bit of a vapor, blob of vapor, and even some clouding up here. And then we see a little bit of a surface tap from here to here, with maybe some of the thicker banding and the thicker water was able to churn up and actually show up on this 3-dimensional radar. Usually over land, when we get debris and dirt and some of the other things, it shows up much better within the field in a darker image. So the blues definitely represent water vapor imagery for that. So that's the only rotation I could really find out of this system. And I think when we go to the next frame, you can see the convection really blow up, which supports that rotation. Seems like the rotation may have actually helped the convection blow up just a little bit more. But we'll take a quick 3D image look at that as well, and you can see how high the cloud tops were. They were about 20, I would say about 27, 28,000 feet up. And here's that area of convection right here. Now we don't see any more rotation after that. Maybe a little bit of a blob right here, and I don't know if you can see it or not, but it's right about here in the image. See, I'll move it around, put it right back in the middle of the circle, and there you go. So definitely a little bit of rotation showing up on the radar, but not very much. And if we put this back into motion, we can see the entire activity, the swath of activity that went over the area right about. This was about 3:20. Let me go back and look at the timestamp, and right about there. Let's go here, and this is at the timestamp here says 2021Z, which is in UTC, so that's universal time. 2021 would be about 3:21 p.m. and then the next frame is 3:24 p.m. So that's about the timing of this convective cell that passed over the area to show that rotation. So here's more of that rotation as it went off to the northeast, and you can see the water capping out here, and that's all that convergent wind heading towards that funnel cloud. So we'll wait to hear back from the National Weather Service. Until then, keep your eye to the sky. Watch those convective cells when those lines of thunderstorms are coming, and you see those on radar. Beware of them, and do not take them lightly, because sometimes they can spawn low-level rotations right there on the beach. And if you have kite gear, sailing gear, anything like that, it can definitely pull you out into the ocean or do some serious damage to your gear, if not yourself. So keep that in mind, and until then, take care. And Rick, hopefully this will be helpful for you in your forum. And once we hear back from the National Weather Service, maybe we'll do another video and talk a little bit more about it. Till then, thanks a lot. Take care.